So in this video, I'm going to discuss about the important concept of nets. Right? So in this, first I will define what we mean by a net, and then I will be giving examples of nets for various solid surfaces. So let's move on. So what is a net? Now put simply, a net is nothing but a two-dimensional representation of an unfolded three-dimensional shape. Have a look at this. What happens when we unfold a three-dimensional shape? Right? You will get a two-dimensional representation, that is, we lay it flat, and that is what we mean by a net. Now this definition implies that a net, when folded, results in a 3D shape, or a 3D shape, when unfolded, results in a net. Both are one and the same thing. Now this will be more clearer with the example that follows. I mean, this is one of the most common examples that you can have. You just unfold a cardboard box and lay it flat, and you could have any cardboard box. It could be a matchstick box, or it could be a box in which you had your TV, or any box. Just unfold it and lay it flat. Then the resulting 2D shape, that is, which is the unfolded shape of the box, right? The unfolded cardboard box will be called as the net for that box. So this is how it would look like. So for example, when you unfold the box, this is just one example, it would look like here, then you start folding, and this gives you the box completely. Or you can work reverse way around. You take this box, unfold it, and then what you get is a net for the box. So this is the net. So what is a net? Let me reiterate. A net is a two-dimensional representation of an unfolded three-dimensional shape, which is clear from the example here. So now, having understood what do we mean by a net, let us try to see some examples of nets of the kind of solid shapes that you find out in your day-to-day lives. So let's start first with the net for a cube. So this is the net for a cube. Now when you fold this, right, you can make it out a cube. So for example, these are the four faces of a cube. We can just say this 1, 2, 3, 4, 5 and 6. So when you fold these four, right, so you will have something like this. Okay, so when you fold it, so when you fold this 4 at 90 degree each, all of these are folded 90 degree, and then this becomes the top cover of the cube, and this becomes the bottom cover of the cube, right? So this is the net for a 3D shape, and then we can make a cube like this using this net. Now let us take another example, which is that of a cylinder. So the net of a cylinder would look something like this. So what happens? Let us say that you have a cylinder, and you cut it from somewhere. Let's say you cut it from here, and then you just open it up. So when you cut that cylinder from here and open it up, you will see that you will get a rectangular flat surface like this, plus you will have two circular surfaces like this. Now equally, if you want to get the cylinder back, you just fold this in a round circle, and these two will become the top and the bottom lids of the cylinder. So that is how the net for a cylinder looks like. Now let us move ahead and explore a few more nets. Now these are the nets for a cone. Now it is interesting to see the way in which we can form the cones. So for example, what we did is we took a circle and just cut 1/4 of it, right? And these small strips that are here, they are just helpful for us to stick them, right? So when you roll this along this point, let us call this point P. When you roll this along this point, you will get a cone, right? Same thing you can get here, but in this case what we have done is we have cut a circular shape, right, in half. So we have half a circle, right? It's half the circle. And when you fold it along this line, then you get another cone. Similarly, this is a 3/4 of a circle which we have cut over here, right? And when I try to stick these two together, right? I fold it a bit and I stick these two, I get another cone. Now what is going to be the difference in these three? It is obviously going to be in the diameter of the cone that you see, the diameter, right? This will have slightly bigger and this will have the biggest one. That is because of this length that is available to us here. So these differences are coming from that. You can just try that out on your own using a simple circle, and you can just try that. That will give you a better idea. And now a famous example of a net for a pyramid structure. So if you have a pyramid structure, which is also called as a tetrahedron, so if you see that this pyramid has this one face, another face, then there is one face in the back and another face here. So it has 4 triangular faces and one square base. This one is square in the right. So this is how the net looks like. So this becomes your base, and these 4, 1, 2, 3 and 4, right? When we fold this up, right? When we fold this up to meet them, fold this up and get them to touch at this point, right? Then it will become like a pyramid structure. So this was our discussion on net, and we also saw the common examples of nets for the three-dimensional shapes. Now if you have a look at the textbook, it has some very interesting examples, right? And it is one of the important skills for us to be able to visualize a net is to see in the mind how you are going to unfold it, and then how does it look like. So that is what should be gone through in mind. For example, if I have a pyramid, I would just go through in mind what happens when I unfold these things. When I unfold the pyramid, then how does it look like? So that type of visualization skill is very important for us to be able to recognize or to come up with a net for a solid shape. And the other important thing is, it is also possible for us to have multiple nets for a same surface. For example, try making different nets for a cube. Just try it, and you will find it quite revealing. Okay, so that was our discussion on nets, and see you soon in this next session.